I'm going to start over then. Welcome everyone to SQL Day. Thank you to all of our sponsors for making today possible. I like to talk about window functions because I first really realized that they were around in SQL Server 2012. I had used them before, but I didn't realize they were a special group, the group that came out in 2005. And what I found over the years at speaking at a lot of events like SQL Saturdays and Past Summit, that many people were not familiar with these, and they could really help out with their workload, with their what they were trying to accomplish with their SQL servers. So there's so much to talk about with window functions that I've actually divided this into two different talks, one about just an introduction to what they are, and then the other about the performance, handling the performance. So I'm Kathi Kellenberger. I work for Redgate Software. Currently, I'm the editor of Simple Talk and a DevOps advocate, but I'm switching jobs in about a month. I'm going to move to the customer success team. I'm an instructor at Launch Code, which is a nonprofit in St. Louis. I am a lifelong learner and teacher, and you can get a hold of me at my email address there. I've also got a Pluralsight course on window functions. It was written quite a few years ago, so there's probably not quite as up to date as I would like, but it is out there. It's a pretty good introduction. So first of all, I'd like to just kind of give a brief overview of what window functions are in T-SQL. They have nothing to do with the Windows operating system. This is a standard piece of functionality added to T-SQL and also to many other database platforms. I'm going to be specifically talking about how they apply to T-SQL, but you'll see these in other systems like MySQL or Oracle. And the reason that these are different is because they operate on a set or window of rows. So I think of it as looking through a window at the rows I'm going to be applying this function to. Window functions always have an over clause. So if you've written a query with an over clause, chances are you've used a window function. And you can only use them in the select and order by clauses. One of the advantages is that they make queries easier to write, but they don't always have better performance. Sometimes they do, but not always. This is a brief history of window functions. In 2005, the ranking and window aggregates were around, and at that point, I didn't even know there was something special. I just knew I was using them, row number especially, and I didn't know that there was anything special about them. In 2012, Microsoft added several more window functions that I'll show you the different performance. There's a couple of issues with performance, not on all of them, just a couple in particular. In 2019, they have taken care of that issue, and 22, there's not any difference in performance. However, they've added this new thing called a window clause. I can't really demonstrate that today because I don't have the public preview is not available yet, but I've seen it demoed. And basically, if you have a query that has multiple window functions in it and they have the same over clause, you can use this window clause to just type it out once. So it's just a little convenience. So first, let me talk about the over clause. So the over clause there's three different things that can be in the over clause. The first is partition by. If I don't want my calculations to cross a boundary, let's say I want the calculation for each customer or for each month, I will use a partition by. It's optional, but it's always supported for any of the window functions. The order by is required in some cases. It's either required or it's not supported. And those are for the functions that require a particular order of the rows. So for example, row number requires an order by, because SQL has to know how you want those rows lined up when you're applying row number. The frame is required for some of the functions. However, there is a default. So if you don't supply the frame where it's needed, SQL Server will use the default frame. This gives you very, very granular windows. So I think of partition by as a window in my house that's divided up into separate window panes. Right? I have a window next to me. It's got two different panes that I can look through, but I think of it as all as one big window, but I can also think of each little pane as a window. The frame is similar to stained glass. So if you think of, I know in the United States, we have a lot of churches with stained glass windows. We have very tiny little colorful sections. And that's what a frame is like. It gets that window that a particular row, when it's using that function, looking for a very, very tiny little window. When we think about performance, we often think about using execution plans. And hopefully many of you have worked with execution plans. If you haven't, don't worry too much about that, but I encourage you to start learning about them. And there's a few that I look for when I'm tuning these queries. These you'll see, one is called a sequence project, and that just means that the output was added to the results. It really is not a performance issue, but you'll see that when you're working with window functions. The other is the segment operator. You probably have noticed that with other aggregate functions as well. This will show up if you use partition by or order by. There's nothing really to worry about. That's just how this works. Here are some to watch out for. Sorting can be an issue. Sorting is often an issue with SQL Server, but if I'm using partition by or order by, I will typically see a sort. Sometimes I can't get rid of that, but often it is the bottleneck in the query. I'll also see these work tables. To get this functionality to work, SQL Server will create temporary objects, and the window spool typically will go in memory, but not always. And I'll explain in just a little bit about how to know that, where it goes and what to do about that. There's also a table spool. Typically, the table spool means that it goes in tempdb. There's a work table created in the background, is created in tempdb. Unfortunately, the execution plan, even though it does show this, it doesn't really show the impact that this makes. It kind of is a little bit misleading. There's a new operator that you may have seen called a window aggregate. I have not seen any issues with this one showing up. And in fact, I am very happy when I see that because that means that some newer functionality is being used. Any questions before I move on to the next little section? No questions? Okay, thank you. Okay, so I'm going to move to a demo. I'll be using AdventureWorks plus an additional, I think there might be an additional table that's outside of AdventureWorks, but that's what I'll be using here. And I have Statistics IO on. and also the execution plan turned on. So first, let's just take a look at this query. This is a window function query. Notice that it has several different window functions. I'm using row number. I'm getting a grand total with sum. I'm also getting a running total with sum and an order by in the over clause. You can see that even though I'm using sum, I did not have to have a group by here. So that's the beauty of one of the advantages of window functions is that I don't need a group by when I'm doing aggregation. I'm going to ignore that. So if I look at the statistics IO, I can see, so it has a logical reads of 689. That's what it took to scan that table. There's no where clause, so it's a scan. But the work table took a large number of logical reads and a large scan count. If I look at the execution plan, again, there's a lot going on in this query, but I'll see some of those operators I showed you. The window spool operator, that's a good one to see because it means something probably went into memory. The segment operators, those are fine. Table spool, that one's for sure. tempdb. I've got an expensive sort. The sequence project and segment operators that I talked about. So the things I would be concerned about here are the sort and the table spool operator and possibly the window spool operator. Those both show a small percentage of the cost, but they could be a large amount. It's just not telling us that. So I'm going to compare each type individually. And it's basically the same query that I showed you before, except broken down into individual parts. So if we take a look at each one, notice that the ranking function had 689 logical reads, and we'll see that on every single one of these because each one scans the table. But notice that the logical reads is 0. So that tells me that this work table was created in memory, and that's what I really would like to see. However, here's one, the aggregate function, where the logical reads for the work table were really high, and I see that in a few other places. I see that with the aggregate, I see that with the running total, I see that with first value, and I see that with statistical functions. So I'm seeing a large work table created in tempdb in several places. If we look at the execution plans, we'll see basically how each one is affected. Like the first one, we've got that sort. If I look at the second one, we knew that the second query was the window aggregate, and notice that that table spool that's created in tempdb just shows a small percentage. That's really not accurate, because if I go back and look over here, I can see that this did take up a lot of resources. So what we're going to do today to get started is just work through this and see how we can improve the performance of each of these queries. Any questions at this point? No? Okay, thank you. Okay, so what have we looked at so far? We've seen that ranking functions and lag and lead, I don't think I specifically pointed that out, but those two are the ones that don't show a large work table, or at least it shows 0 for work table. That means it's created in memory. They are both using work tables, but they are not taking a lot of resources. So we have 4 other situations where the performance is not great. So what can we do? The first thing that you might consider when doing this, and of course you can't always add an index, but Bingon had suggested using a POC index. So if you have a copy of his book or seen any of his sessions on windowing functions, you'll hear him talk about that. And I think that he came up with this. That's where I learned it. And basically he's saying if you add a non-clustered index, you should start with the filtered columns, then add the partition by columns, then the order by, and then any additional columns in an included is covering. Sometimes this will work. It will help with the queries I'm writing, but I'm not really doing any joins. I'm just looking at one table query. So you may or may not be able to eliminate the sort by using this. And of course, you just can't go adding an index for every query that you write. You've got to look at the entire workload. But I'll go ahead and show this just to show how it does work. So I'm going to pop back over to the demo, and I'm going to add this index. So if I look back at my queries, I've got, they all have partition by customer ID. So that's my P for partition. Some of them have an order by, not all, because they don't all support that. And that's where I put my O, PO. And then I have a couple of other columns that are in my query. So if I am including those here to avoid a key lookup. So I'm going to create this. I haven't done that already. Nope. And just by adding that, let's see what's happened to our set of queries. So if you look at, actually, I'll just show you that in the messages. If we look at the messages, I've got the previous count, the previous logical reads, okay? By adding that POC index and getting that data lined up the way that I need it for the window function, I was able to eliminate that work table. So in this case, I'm also using a smaller object. So I was able to get the logical reads down on the ranking function, and also lag. I was able to get, actually in all cases, just scanning the table, I have a smaller number of logical reads. But now I do still have a work table with lag, but it's 0. So those are improved, and there's not much more I can do with those. So lag and ranking are fine. If I look at the window aggregate though, even though I have a smaller number of logical reads for scanning the table, my work table is still very big, just as big as it was before. And that's the case for the running total, first value, and the statistical functions. So I've improved 2 of them, about as good as I can get, but there's still issues with the others. If I take a look at the execution plan, we'll see that for the ranking, that is the sort is gone. So I was able to eliminate the sort for the ranking and lag. However, if I look at here, I've still got that table spool. If I look at, this is the running total. The running total shows a window spool, but I can tell by looking at the statistics IO that that was created in TempDB. So that's a problem. So it's a kind of very misleading. So any place where it looks like I eliminated the sort everywhere, but I still have some issues. So are there any questions at this point. No, okay, thank you. So far, by adding the POC index, I've been able to improve the performance of the ranking and lag and lead. But I've only gotten a slight performance improvement on the other types. So what else can I do? This is where framing comes in. Several of the queries require a frame in the over clause. If you recall, I did not use the frame. I did not specify the frame whenever I wrote those queries. So in three situations that the frame would improve this, there is a default frame. The default frame always puts the work table in tempDB. If I specify the correct frame, it will go in memory most of the time. There's no guarantee that it's 100%, but I've never seen it otherwise. This applies to moving aggregates. That's like your running totals, your 3-month moving average, things like that. And also first value and last value. So those are the only 3. I didn't have first value and last value. I think I just had first value in the demo. The frame is to me, it's a bit difficult to write. I don't like how it sounds because you may have seen it before. Rows between unbounded preceding and current row, or rows between current row and unbounded following, things like that. It's a little difficult, I think, to get used to. These are the words that you need to know. Rows is a positional operator used to define the frame. This is the one that works with memory. This is the one we want. Range is a logical operator used to define the frame. This is the default operator that SQL will use if you don't specify. And range always works in tempDB. So range does not perform as well. The other issue with range is that it's a logical operator, not a positional operator. So if I have 2 rows with the same, let's say it's order date or same value in that order by of the over clause, it's going to group those together as the same value, and it's going to give you a possibly incorrect results you're not expecting. It's working the way it's supposed to. It's just the wrong thing. So unbounded preceding means the very first row of the partition. If I'm looking at 10 rows, it's row 1. Unbounded preceding is the last row of the partition. If I'm looking at 10 rows, it's row 10. The current row is the row where the window function is doing its calculation. So here's some examples. This is rows between unbounded preceding and current row. There is a shortcut to this. Rows, I think it's called rows unbounded preceding, maybe. I don't usually use it because there's not shortcuts for all of them, and I want to see exactly what I'm talking about, but you will see the shortcut. So here's my window. There's 15 rows that I'm looking at. When I'm on row 1, I'm doing the calculation just on row 1. When I'm on row 2, I'm doing the calculation on row 1 and 2. The window is expanding. When I'm on row 3, I'm looking at rows 1 to 3. When I'm on row 4, I'm looking at rows 1 to 4, and it continues on. So another example is rows between unbounded following and current row. This is the opposite direction. So at this point, if I'm on row 1, I'm looking at rows 1 to 15. If I'm on row 2, I'm looking at 2 to 15. If I'm on row 3, looking at 3 to 15. So this is the opposite of what I showed before. You could use this to do a reverse running total. There's also some syntax, rows between in some number, preceding, and current row. So in this case, I'm looking at just one row. I'm looking at the 2 rows. I'm looking at 3 rows. Now here's the point where I have, this is as big as my window is going to get here. So then it starts moving. Okay, so this is that 3-month moving average or a week moving average, things like that you'll see. Let's take a look at the demo. Okay, just to remind you, these are, let's see, in the right demo. I think I went backwards. Here we go. This is what I ran before. I did not specify the frame. This is the running total, even though the frame is required. This second one is what it's actually doing. Range between unbounded preceding and current row. That is the default. You can see it's a lot of typing. And here is the correct frame for that query. So let's take a look at that. And if I would look, I'd probably find where there's a duplicate, same customer has placed an order on the same day, and if I use range, you'll get the 2 values the same at one point. Let's look at the statistics IO. That's where I really want to look. So this is the without the frame. I didn't specify it, so I got the default, not specified. Here's where I went ahead and typed out range just to show you that these were identical. Here's what it looks like whenever I type out the correct one, but I have to type it out. Logical reads 0. Okay, so the execution plan, as far as the execution plan is concerned, these are all equivalent. I'm pretty sure they all have the same identical execution plan. They all show that window spool. However, this is the only one that uses that work table in memory. The other 2 create it in TempDB, and you cannot tell that from the execution plan. I can only see that in this case from the statistics IO. And believe me, this is small tables. If you had large tables, you would feel this impact. You would see these queries that, with range, you'd see these 2 running really, really slowly. And I have some timing results that I'll show you at the end. Okay, I can do the same thing with first value. Here I've left the frame out. Here I've used the correct frame. And I get that large amount of logical reads. So you can imagine if I had a table with 1,000,000 rows, how big this would get. It would be just an unbelievable number. And here, when I use the frame, I have 0 logical reads. Again, that window spool operator in the first case is created on TempDB, and in the second case, it's created in memory. Are there any questions at this point? Okay. I am moving on then. So far, I've applied a POC index, which has helped all of the queries, and I have applied the frame in the two situations where it will make a difference, or where it's, I should say, not make a difference, but where it's supported. I can't use a frame in the other situations. And so I have good performance here. I still have some issues. I still have poor performance on the window aggregate and on the percentile. Still have poor performance with those. The problem is if you're running lower than 2019 and lower than Enterprise Edition, you're kind of stuck right there. You're pretty much better off using another technique. So there's, you know, if you're in a downward, there is a hack. We can get better performance out of this. There is a hack. Again, it's from ITSEC. But at 2019, then things improve for those situations. So in 2019, we have this thing called batch mode on row store. This is one of the intelligent query processing features that you may have heard about. So batch mode is part of column store. When you're working with column store, I don't think it was the very earliest version of column store. I think it was like an update maybe around 2014. When you're working with column store and it's a large number of rows and you're doing aggregates, SQL Server will break the query or the rows down into smaller batches and then combine it later. This is not parallelism, it's something different. So this feature will automatically improve window aggregates and those statistical function. It kicks in at, in my experience, maybe different for others, but I saw it kick in around 100,000 rows. And it actually allowed me to skip the frame to get better performance. However, if that order by column is not unique, then I could get incorrect results. Oh, I forgot to run this little piece. This is just that in proceeding. I just want to show you that if you're using in proceeding, range does not work with it. So let's ignore that. And if you're doing that moving window, where you have like 3 rows moving, you have to specify the frame there. Otherwise, you don't get the right, you can't do it. You have to. All right, so demo 4, batch mode on row store. So what I'm going to do is create a bigger table because there's no tables in AdventureWorks that are quite big enough for to get this feature to kick in. So remember our aggregate query and our analytic function. Remember those two. These are the two that I'm still getting a large number of logical reads on that work table. This is actually different queries because I'm working with bigger tables now. So I do have a large number of logical reads on scanning the table because it is a new table. The queries are very similar. And let's look at that just a minute and look again at that execution plan. Again, it's showing in this case, it is showing the table spool. And what's this one showing? Table spools. So at least in this case, it is showing you that it's using table spools. However, it shows that the cost is very small, and actually it's pretty big. That IO is really big there. Okay, so all I have to do here is switch to 2019 compatibility mode. I'm using SQL Server 2019, but I've had the database in 2017 mode up until now. I will rerun these queries. And they have a lot of rows. So here, I'm bringing back over 200,000 rows, and it does take some time to populate the grid. Notice that I was able to get the work table to now show up in memory instead of tempdb. This is a very, very important difference. This will run much faster than it would have otherwise. When I look at the execution plan, the very first one no longer shows that what was that called? It's table spool. It now shows this new operator called window aggregate. So when I see that, I can be pretty sure that the work table was created in memory, and it's also, let's take a look over here at the properties. It's using batch mode. Okay, so even though it doesn't have a column store index, starting with 2019, for certain queries, that batch mode will kick in. And I can see, so it had 270 batches. I thought somewhere I could see, let's move it over to this and see if I can see it. Batch mode on row store. I'm not seeing it, but I thought there was some place I could see the batch. Okay, just expand that. Nope. I'm not seeing it. I might be clicking on the wrong thing. I thought there was something that I could expand and see the values on how it divided the batches up. Let's look at that one. 270. I am not seeing it, so I'm not going to worry about that. But anyway, that batch mode, even though it's just a row store query, it's using batch mode. That's 2019. That is also Enterprise Edition. I have not heard if that Enterprise Edition requirement will be changing with 2022. Have not heard anything about that. If I look at the, let's see what that one was. Percent rank. If I look at the percent rank query, I see that window aggregate operator. You see it a couple places, and I still see a sort. So I could add, if I needed to, I could add an index to help with the sort. But it's kind of interesting. I have a book on, actually 2 books on windowing functions, and in the book, I try to figure out how to actually get the same results without using percent rank, come up with the formula. Under the covers, it's using sum over. So that's why I'm seeing 2 of these. Under the covers, it starts with the sum over and then builds on that to get the percent rank. So I thought that was kind of interesting. So what if you don't have Enterprise Edition? What if you don't have 2019? If you really feel like this would benefit you can use this hack from Itzig-Bingon. And I've set this compatibility back to 2016. I can't change it to standard edition, but I have tested it on Express edition. So I know this works even in standard. So all I'm going to do is create a temp table and add a column store index to it. I'm not going to populate this temp table. And here I've added outer apply and joining on this temp table with outer apply. Or I could use a left outer join, something like that, but I really don't have anything to join on here. So remember, previously, I would get crummy performance on this one unless I'm running in 2019 mode. And I look at the statistics IO, I'm seeing what I want to see here. If I scroll over, I also see that's a logical reads 8, or 0, I mean, logical reads 0. So that's good. And I look at the execution plan, I see that window aggregate that I like to see. So all those previous operators, the was it the table spools that I was seeing before? Those are gone. So that will work. Any questions at this point?
Previously, we had a question about what are counts of rows?
What are counts of rows?
Rows you described, but what are counts?
Could you type it in the, I'm not sure what you're saying. Cons of rows. Oh, so rows versus range. Rows versus range. Okay, let me talk a little bit about that then. I mentioned that, let's go back to this one. For the functionality that exists right now, always use rows. There's no detriment to using rows. Always use it where you need to use a frame, require a frame. Always use it. There's no problem with it. If you have, so the specification from the ANSI SQL committee have defined additional, what is the word I'm trying to say? Additional functionality with range. So there's additional functionality with range that has not been implemented in SQL Server. So at this point, always use rows. Now in the future, should Microsoft implement the other functionality that goes with range, and this has to do with time periods. I have not really seen an example of how this works, but it has to do with time periods. Then, there would be, then you would use one or the other depending on what you were trying to accomplish. So right now, there's no detriment to using rows. However, range has many problems. Number one, performance. Number two, you will not always get the results you expect. Okay, does that answer that?
That was the question from the internet.
Okay.
We have a slight delay on that.
Okay. So I think that probably explains it. So there's many problems with range, no problems with rows right now with the current functionality we have. Okay, so let's take a look at, like, if I'm working, let me put my compatibility is still down. Okay, if I'm working with something like this earlier than 2019 or not on Enterprise Edition, this doesn't scale very well. This particular one, a window aggregate. Okay, this one doesn't have the order by. So let's say I want subtotals. This is the one that doesn't scale very well. If I'm on, what were my subtotals on? Okay, so on sales order ID. So I've got a subtotal here, a subtotal on this one, and so on. That one doesn't scale very well. If you see poor performance, you could always use one of the older techniques, like separating the logic out, something like this, with a common table expression or a derived query, you know, put that this in a subquery down here. You could do that. Those are going to perform better until you get to 2019 and Enterprise Edition. So what I want to do is just show you some of the timings that I've done. And since there haven't been many questions, typically in person, I have a lot of questions. So I have gone through this pretty quickly, hopefully not too fast. Because if something that wasn't clear, I can always go back. I still have some time. So here's a situation where I wanted to look at the performance, and I looked at a table with 30 million rows. And I looked at, and this was the window aggregate, just like that little example I just showed you. In 2017, if I don't use that hack from ITSEC, running a window aggregate took 45 seconds. If I used the common table expression, it took 15 seconds. So pre-2019, it was faster to use the common table expression for this particular one. Remember, I've taken you through all the different types of window functions, and this problem is not across the board. It's only in certain ones. In 2019, I was able to get identical results. This is an average. So I ran them several times to kind of get an average. And the window aggregate and the common table expression both performed very well, both at 15 seconds. Another thing that you can do is have correlated subqueries. Correlated subqueries work fine if you just have one calculation. I don't have the results here. I used to have it in a previous version of these slides, but with a correlated subquery, if you have multiple values you're trying to get, that performance will just it will be linear increase in time. Okay. I've also looked at the running total, the same data set. If I did not specify the frame, I left the frame out. If I leave the frame out, that's going to be range. It took 6 minutes. In both of these experiments, I did not populate the grid because that grid takes a while to populate. In both of these cases, I dumped the results. I threw away the results. I threw them into a temp table, I think. You can also change a setting on Management Studio to not have the results show up. But the problem with that it's like you have to turn it on, close the thing out. You know, it's a lot of changing settings and restarting Management Studio. So I didn't do that, but I could. So 2017, the default frame, meaning I said sum whatever over partition by order by, it took 6 minutes. If I did specify rows, it took 1 minute. When I changed the compatibility level to 2019, both of them improved. I get better performance whether I use the default frame or used rows. So I got better performance in each case. So it's, if you have especially like a data warehouse implementation or something where you're doing calculations on large aggregates, that's really a great improvement. So that's that batch mode on row store kicked in. Oops. I want to show you one more thing as I have a little bit of time. Here's an article I wrote last year, and I started out writing the article about just comparing all the different types of window functions and the differences in performance of using different techniques. And I ended up finding so many ways to get the same results with lag that I decided to just write the article about lag. And I believe that this link is in the slide deck. But what I'm going to do is scroll down to the very end here. These are all the different techniques that I use, and I have timings as well. If I just use lag, I did not use a temp table. It was 300 milliseconds and 365 logical reads. This was it was a big table, I think. Let's see, what was it? Maybe it wasn't. To go back and look at what the temp table, maybe it wasn't even a big table. I can't remember, but you can go out and look at the article for yourself. If I did a self join the table to itself. Remember, lag pulls I didn't talk a lot about lag here, but lag pulls a column from another row. So if you don't have lag, you might do a self join. The self join took 20 seconds, not just milliseconds, 20 seconds. It still didn't have a bad logical read. I could use a derived table, so something in the subquery in the from clause. It took 2 seconds. It was a bit faster, still a large number of logical reads. I could do a common table expression. These two were identical. Outer apply. I see some folks talk about outer apply like it's the solution to everything. Outer apply was pretty slow. But then I thought, what could I do to make this better? So I added a temp table instead that was already in the shape it needed to be in. And then it was pretty fast. Then it was almost as good as lag, at least in this situation. Okay. The self join on the temp table. At this point, I just continue to use the temp table. I tried a scalar UDF. I could not even get it to run. I think I probably let it run for 20 minutes before I killed it. An inline table valued function, 12 seconds. So this is what I felt was a pretty interesting exercise, and I encourage you to take a look at it. So before I get done, are there any additional questions at this point? Okay. Here's some resources. I don't think I've got that lag. Let me just add that lag. I don't have it in the slides, so if I put it, hopefully that went to everyone. Okay, so I have written 2 editions of expert T-SQL window functions. Itzik has also written 2 editions of his book. If you want to learn more about these, I would suggest grabbing any one of those. The second edition of either mine or Itzik's, they're both really good. I'm saying mine's really good. Okay, I think it is. I think it's good. I know Itzik's is. I have a Perl site course. I have articles out on at kathysql.com. I have many articles on Simple Talk, and also the slides and code are available out on GitHub. And I also will upload the slides and code to the place we're supposed to for this event. So I'll do that shortly after I get off of here. So if there are not any other questions, one thing I just want to encourage you is learn more about these. There may be queries that you're having difficulty writing that these functions could really help you. Lag is my absolute favorite function in the world ever. And I often hear that it's a game changer for a lot of teams. So if there are not any additional questions, I think I am done.
Okay, no questions.
Okay.
Thank you very much.
Thank you. Thanks, everyone. Bye.